Hello and welcome to this video where we will be finishing section 3.3 and doing section 3.4. Both these topics are pretty simple. You'll remember in our last class we talked about two types of forms. We talked about slope-intercept form, that's the y equals mx plus b. And then we talked about point slope form, the y minus y1 equals m parenthesis x minus x1. Now let's talk about why we use these. We use this one for graphing. It's very easy to graph when it's in y equals mx plus b. For example, if it was y equals 3/5 x minus 2, that's easy to graph because it's already in y equals mx plus b form. My y-intercept is -2, so I go down 2, and my slope is 3/5. That's rise over run. So from the point, I go up 3 and over 5. We really like y-intercept form for graphing, okay? Now, why do we use point slope form? We used point slope form yesterday for writing our own equations, writing a linear equation. This form is best when you need to write a linear equation. For example, if they say write a line that has a slope of 6 and goes through the point to 11, well, we can do that using the point slope form. I would just write y minus, I'd plug in the y part of the point, which is 11, equals m, which is 6, open parenthesis x minus the x point, or the x part of the point, which is 2. And there it is, there's the answer. And if we wanted to go to graph this, then we could convert it to slope-intercept form by distributing the 6 and adding over the 11, okay? But for writing equations of the line, we like to use point slope form. For graphing, we like to use y equals mx plus b, the slope-intercept form. Today, I've got to talk about this third form, which is standard form. Now you might ask, what? Why do we need another form? Well, each form has its own advantage, just like I went over here. This form is great for graphing. This form is great for writing linear equations. And this one here is great for chapter 4, which is going to be talking about systems of equations. So let's talk about standard form. Standard form, basically, you'll see that you need to get the x's and the y's to the same side and the number by itself. So step number 1, get x's and y's to the same side. Step number 2, get rid of fractions. If you have fractions, you got to get rid of them. Get rid of fractions. You'll do that by multiplying by the common denominator. By the common denominator. Step number 3, you'll want to make sure that the x, the number with the x, is positive. So let's try one here really quick so you can kind of get an idea of what this is talking about. Let's do it with this one that we had right here that I already wrote up. This y equals 3/5 x minus 2. Right now that's in this slope-intercept form. But what if they said, write this in standard form? And again, standard form is the form that we're going to be using in chapter 4 a lot for solving systems. So to do this, step number 1, we'd want to get x's and the y's to the same side. So I'd go ahead and minus the 3/5 x over. So notice I would have -3/5 x plus y equals -2. I basically moved it over here. I need to get rid of fractions, so I need to multiply by the common denominator. The only denominator I have is 5, so I'm going to multiply both sides of this equation by 5. So I'm going to multiply this by 5 and this side by 5. We'll have to distribute that 5 in. When I do that, I get -3x plus 5y equals -10. We're not quite done. The rule for standard form is that the x value has to be positive. Right now it's negative. So I'm going to go ahead and multiply everything by -1, again, on both sides. And when I do that, this is going to become positive 3x. This is going to become negative 5y. And this is going to become positive 10. And that right there is standard form. Ooh, I like standard form because that's what we're going to be using in chapter 4 for solving systems of equations. So basically, lines can be written 3 ways. Okay, they can be written in point slope form, they can be written in slope intercept form, and they can be written in standard form. Well, now it's your turn. Here I've written up 2 equations, number 1 and number 2. Number 1's in slope intercept form, the y equals mx plus b form. And this other one's in point slope form. What I'd like you to do is get these to standard form, okay? So again, if it's a point slope form, you'll go to y equals mx plus b and then go to standard form. Go ahead and pause the video now and let's see how you do. Welcome back. We're trying to get things to standard form where the x's and the y's are all on the same side. I'm going to go ahead and add 2x to both sides. That gets me 2x plus y equals 3. And that's it. We're done. Well, I made a really easy question. I should have thought about that a little harder. The x is already positive, and so we're done. That's the answer. You just got to get the x's to the same side. X's and the y's to the same side. Good. Number 2, we're going to have to distribute the 1/3 here. I get 1/3 x minus 10/3, and I have a y plus 5. Okay. I got to get the x's to the same side and the numbers on the other side. Let's do that now. If I do that, I'm going to get negative 1/3 x plus y, and then I'm going to minus the 5 over. Minus 5, minus 5. Man, that makes me want to use some calculators here. It's got some fractions in it. Negative 10/3 minus 5, I get negative 25/3. Okay, I'm going to go ahead and multiply everything by 3, because that's the common denominator. Times by 3, times by 3. When I do that, I get negative x plus 3y equals negative 25, because I took the 3 and distributed it in. This isn't quite the answer because the x needs to be positive, so I'm just going to go ahead and change the signs here. This is going to basically, when I multiply by -1, I'll get x minus 3y equals positive 25. So basically, it just changes the sign. And that's the answer you should have got for number 2. That was a little more intense than number 1. Okay, well, here's another one for you to try. Let's do this one. This is a review from our last lesson. This is question number 3. I'd like you to pause the video, go ahead and write the equation of a line that has a slope of negative 2/3 and goes through the point 9, negative 4. You're going to do this. You're going to want to use point slope form. However, in the end, they ask you to write the answer in standard form. So go ahead and get it in point slope form, then switch it all the way around into standard form. Good luck. Okay, let's try this problem here. We're going to write up our point slope form, which is y minus y1 equals m x minus x1. Let's plug in our values. This is our m, this is our x1, and this is our y1. So I've got y minus a negative 4 equals a negative 2/3 x minus 9. That's y plus 4 equals negative 2/3 x. When I take that in, ooh, and negative 2/3 times a negative 9 comes out to be plus 6. If you struggle with that, you could have called 9 over 1, multiply the top with the top and the bottom with the bottom. If you're bad with fractions, you could also just use your calculator. I'm not done yet. I got to get it into standard form. So that means I got to get all my x's to the same side. So I'm going to go ahead and plus 2/3 x to both sides and minus 4 to both sides. When I do that, I get 2/3 x plus y equals 2, because 6 minus 4 is 2. Okay, we're not quite done yet. Remember, you can't have fractions. No fractions allowed. So I'm going to go ahead and multiply everything by 3, the common denominator, and that gets me 2x plus 3y equals 6. There it is. How'd you do? And now it's time for parallel versus perpendicular. Okay, you guys probably all know this. We know that parallel lines are lines that never touch. But if I were to ask you what's true about their slope, that's the real question. So when you look at perpendicular or these parallel lines, what's true about their slope? Yeah, they have the same slope. They have the same slope. So if line number 1 has a slope of 6 and line number 2 is parallel, its slope is also going to be 6. That's not true with perpendicular lines. Perpendicular lines meet at a 90-degree angle, and their slopes are opposite reciprocals. Slopes are opposite reciprocal. Now, if you don't remember what reciprocal means, that basically means flipped. So if line number 1 here has a slope of, I don't know, let's go with 2/3, then line number 2, if it's perpendicular, will have a slope that's flipped. So the flip of 2/3 is 3/2, and it will be opposite sign. So it'll be negative 3/2. What if line number 3 has a slope of -8? What would line number 4 have? You might want to think of 8 as being -8/1. In that case, it'll help you flip it. So we'll flip it, we get 1/8, and it's going to be opposite sign. So this time it becomes positive. And so the opposite reciprocal slope of -8 is 1/8. So what if we had to do a problem like this? What if we go back to our line writing and we're like, hey, write the equation of a line that's perpendicular to y equals 2/5 x plus 21, but goes through the point 8, -2. Well, we could do that. Again, anytime you got to write your own line, we're going to go to this form here, our point slope form, and go ahead and let's work on, we know that this is going to be x1 and y1. Now our slope is a little harder. Our slope has to be perpendicular to this line. Well, what's the slope of this line? Oh, the slope of this old line is 2/5. If I'm going to be perpendicular to that, my slope is going to have to be -5/2. Yeah, perpendicular means it's opposite reciprocal. So we flip it and change the sign. Now, if this would have said parallel, then we would have used the same slope. We would have used 2/5 right here for our m. The x value is 8, and the y value is -2. So that's y plus 2 equals -5/2 x plus 20. Yeah, cool. I'm going to go ahead and minus the 2 over. I get y equals -5/2 x plus 18. Okay. So that right there would be our answer if they wanted it in y equals mx plus b form. If they wanted it in point slope form, we could have just left it like this. If they wanted it in standard form, to get standard form, we got to get x's and y's to the same side. So I'd have to move the 5/2 x over. So it'd be 5/2 x plus y equals 18. And then I would multiply both sides by 2 to get rid of the fractions. Remember, no fractions in standard form. So I get 5x plus 2y equals 36. So you can write that answer 3 different ways. Okay, go ahead and pause your video and let's go to the boards. You guys try this one here, this number 3, write the equation of a line that's parallel to y equals 4x plus 911 through the point -610. And then on number 4, it's a thinker problem. Let's see if you can get this one. It says write the equation of a line that's perpendicular to y equals 9 through the point 421. When you're ready to check your answers, unpause it and we'll see how you did. Okay, let's take a look. I'm going to go ahead and use point slope form. Y minus y1 equals m x minus x1. My x1 is here, my y1 is here. My slope is going to be parallel to this, so it's going to be the same. I'll use a 4. It's going to be y minus 10 equals 4x minus a negative 6, which really is just plus 6 because it's minus a minus. That's why minus 10 equals 4x plus 24. And I'm going to add the 10 over at the end there to get y equals 4x plus 34. I'm going to leave my answer like that. Maybe you went the standard form. That's cool. I didn't actually tell you what to do. If you did the standard form, you should have got 4x minus y equals negative 34. Don't forget, you have to minus that 4x over, and then you can't have your 4's be, or your x's be negative. Okay, this is a weird one here. Write the equation of a line that's perpendicular to y equals 9. Remember, y equals 9 is a special line. Special line. Do you remember what kind of line it is? Remember? Horizontal. It's a horizontal line. So to be perpendicular to a horizontal line, what is perpendicular to horizontal? Vertical. And vertical lines are always written as x equals a number. So all we have to do here is look at the point and say, oh, well, what's the x value of the point? That's 4. And so the answer is x equals 4. It's kind of more of a thinker problem than doing all the math and point slope form. Nice work. Let's go to the last part of this lesson, which is section 3.4. It's the easiest in the chapter. We'll get through it super fast. Let's take a look. In section 3.4, we need to talk about graphing inequalities. To graph an inequality, step number 1, you're going to solve it for y. Solve for y. Because we want it in that y equals mx plus b form. That's the easiest form to graph. Step number 2, you're going to graph the line. Graph the line like normal. Graph the line. Step number 3. If it's less than or equal to or greater than or equal to, you're going to use a solid line to graph. If it's just less than or greater than, then you're going to use a dotted line to graph. And in step 4, if it's less than or equal to, you're going to shade down. Shade down. And if it's greater than or equal to, you're going to shade up. Inequalities have infinite amounts of answers. And so in a second dimension problem like this, y is greater than 2/3 x plus 3. Step number 1, we want to identify all the possible solutions. So these are the steps we'll follow. Step number 1, you want to get it equal for y. We've already done that. We're going to graph the line like normal. What's the y-intercept? Oh, the y-intercept's right here. It's 3. So I'm going to go up 3 and put a point right there. I'm now going to use the slope. Here's the slope right here. The slope is always with the x. And this is the rise over the run. So I'm going to rise 2 and run 3. There's the next point. We could go again if we really wanted to. Rise 2, run 3. Okay, perfect. Our next step is to graph the line, just like normal, just like we did in the first section and the second section. The only thing, though, is that it's greater than and not greater than or equal to. There's no equal to sign here. And so because of that, we're going to use a dotted line. We'll always use dotted lines if it's not equal to. So I'm just going through here and I'm erasing this to make it look like it's dotted. There we go. One more there and there. Awesome. Now, if it were equal to, like right here, then we would have used a solid line. The last thing is the shading. This is y is greater than. Because y is greater than, we're going to be shading above the line. I like to think of it as we're going to eat the y on the axis here. So we shade above the line. And that represents all of these points. This point here, 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 this point here. There's an infinite amount of points that are a solution to that system. And that's why we shade. Okay, it's your turn to try a few. Here's number 5, number 6, and number 7. Go ahead and pause your video, and on your notebook, just make a little graph. It doesn't have to be on graph paper. And graph these linear inequalities. Don't forget to decide if it's solid or dotted, and don't forget to decide if you need to shade up or shade down. Good luck. Here we go, number 5. Number 5, It's already solved for y, so I'm just going to graph the y-intercept, which is at 2. I'm going to use the slope, which is negative 2 over 7. That means I go down 2, 1, 2, over 7. 1, 2, 3, 4, 5, 6, 7. There it is. It's a solid line because it's equal to. So I'm going to do solid. Ding. Solid. And because it's less than, I shade down. And so I'd shade like this. And there it is. That's my answer. Let's take a look at number 6 here. On number 6, it's not solved for y, so I'm going to need to minus the 2x over. When I do that, I get y is greater than negative 2x minus 4. Okay, my y-intercept here is down 4. 1, 2, 3, 4. Right there, that's my y-intercept. My slope is negative 2 over 1. So I'm going to go down 2 and to the right 1. Am I going to use a solid or a dotted line? Oh, I hope you said dotted, because it's not equal to. Over here, we had an equal to bar. And so we did solid. But here, this is dotted. And because it's greater than, we shade above the line, up here. That's the answer to number 6. Number 7, tricky. I didn't even mention this. I hate when teachers do that. Let's take a look. Let's see if you can do it. We're going to minus 8x over minus 8x. When we do that, we get negative 2y is greater than or equal to negative 8x plus 10. Got to get y by itself, so I'm going to divide by negative 2. Now, careful. Anytime you divide by a negative, if you divide by a negative number, what do we got to do? Yeah, you got to flip it. Remember, we learned that in chapter 2. So I'm going to get y is less than or equal to 4x minus 5. I hope you remembered the flip. If you didn't, you can fix it now. My y-intercept, oops. My y-intercept is going to be at a negative 5. So 1, 2, 3, 4, 5. Here it is. And my slope is 4. That's 4 over 1. So I'm going to go up 4 over 1 to get to my next point. I'm going to make it solid because it is equal to, but it's less than. So that means I have to shade below the line. Shade below. There it is. The last thing we need to talk about in section 3.4 is understanding what a function is. A function. The best way to know what a function is mathematically is that there's something that goes in and then something that comes out. For example, maybe this function, a line is a function, for example, y equals x plus 3. If I plug 2 in, I end up getting, well, 2 plus 3 is 5 out. Okay, whatever you put in is known as the domain of a function. It's all the inputs, or x values. And the y values that come out, or the outputs, are known as the range. All outputs, or the y values, if you want to think of it like that. That's the understanding of domain and range. Sometimes you might be given a chart and they'll say x is 3, 7, and 11, and this is 9, 49, and 121 for the y values. That's cool. They might ask you, what's the domain of this function? Well, if you have to list it out, you would just say, oh, well, the domain is the x values. It's 3, 7, and 11. We'll use these braces to show a domain. The range would just be a list of y values, which is 9, 49, and 121. Sometimes functions are written in algebraic notation, something like this: f of x equals 2x squared minus 3. Ooh, this right here is function notation. Function notation. Function notation is basically just a name for a function. For example, we would say that this is f of x. The name is f, and x is the variable. They might ask you to find what is f of 2. that basically means I'll plug 2 into the function. 2 is the input, and it'll go through the machine and come out. So let's plug 2 in. So if I did that, I would get 2 squared minus 3. 2 squared is 4, so 2 times 4 minus 3. Well, that's 12 minus 3, which equals 9. That's function notation, and we would say f of 2, or the function when we plug 2 in, is equal to 9, and 9 is the y value. Let's have you guys try one right now on question number 8. I'm going to give you the function g of x. And g of x equals x squared minus 2x minus 11. And I want you to find g of negative 3. Go ahead and pause the video now and see what you get. Okay, well, this notation here, g of negative 3, just means that you're plugging in negative 3 for the x values. So just plug that negative 3 in. When you do that, you're going to get g of negative 3 equals, I'm plugging it in, negative 3 squared minus 2 times negative 3 minus 11. Make sure that when you plug a value in, you do use parentheses. Negative 3 squared is 9, and negative 2 times negative 3 is plus 6 minus 11. That's 15 minus 11, which is 4. So g of negative 3 equals 4. That's our answer right there. Basically, that means the function g, when we plugged in 3, or negative 3, is equal to 4. That's the x value, and this is the y value. Again, this is function notation, making sure you understand what that means. You should also be aware that functions can never have two outputs. For it to be a function, each input can only have one output. That's really important. If not, it's not a function. For example, if I put the number 2 in and I get 8 out, well, that's great. That's a function. But if I plug the number 2 in and I get 6 and negative 6, that's not a function. We broke the machine. Think about how annoying that would be. Imagine pressing the J button on your computer. In fact, J is a function. When you push the J button, this is a function, then it goes through the machine and puts a J on your screen. Could you imagine how annoying it would be if you push the J button, it always gave you a J and a W? You'd be like, no! Why is that happening? I just pushed the J button once. Just give me a J. Okay? Every input can only have one output. With that in mind, you should be aware that some functions might not be functions. For example, if I had this and this, here's function number 1, and here's function number 2, 3, 4, 5, 6, 8, 3, 8, 11. Here's 4, 2, 1, 4, and we get 6, 0, 11, 31. Take a look at number 1 and number 2 and see if you can identify which one is a function and which one's not a function. Okay, hopefully you saw this. Look, when I push the number 3, I get an 8. That's fine. When I push the number 4, I get a 3. That's great. When I push the number 5, I also get an 8. That's fine. And when I push the number 6, I get an 11. This is a function. It's totally all right. Now, some of you might say, wait, there's 2 8s over here. That's fine, because they were different inputs. What's not allowed is here on number 2. Look, when I push the number 4, I get a 6 and a 31 out. You can't do that. This is not a function. Another way to think of it is maybe look at it graphically. If you were to graph this, 4, 6, 1, 2, 3, 4. 4, 6 would be like right here, and 4, 31 would be way up here. They'd actually be in a vertical line. And this is one way to test functions. You cannot have a function have a vertical line in it where it hits it twice. This is called the vertical line test. Vertical line can't hit it twice. If it does, then it's not a function. So here on number 2, definitely not a function. What about if we looked at some funky graphs here? Look at this. Okay, let me draw one here. Let's draw this, or this, or this, or this, or I don't know, this, or this. Okay, looking just at these graphs, which one would not be a function? Which one would fail the vertical line test? Let's take a look. Well, this one here, if I draw vertical lines through it, notice that the vertical line only touches it once. This is a function. Function. It passes the vertical line test. Let's look at this one here. Well, it passes there, but ooh, look, it doesn't pass here. It touches the vertical line more than once. That's not allowed. This is not a function. Not function. Here, this upside down V thing, that's a function. That's good. What about a circle? It touches the line twice. This is not a function. This one, ooh, we touched twice here. That's not a function. And what about this wavy line? Let's see. Oh, doesn't touch, doesn't touch, doesn't touch, doesn't touch, doesn't touch. This is a function. This one's a function because it never touches a vertical line more than once. Hopefully that gets you an idea of seeing what a function is. Each input, each vertical line that represents an x value has just one output, one y value. Here, notice this one, if this was x equals 9, it has two values, two y values, so it's not a function. There are a couple functions that are so popular, they are known as the mother functions. Oh, actually, that doesn't sound very good. Mother function? Okay. Well, anyway, there are a couple functions that are mother functions. They're so important, we want you to know about them and what they look like, okay? These are the most common mother functions, and again, they're so common, they appear all over in the real world, and that's why they're good to know. The first type of mother function, again, this passes the vertical line test, is a line. A line is y equals mx plus b. That's a mother function. Here's a parabola. A parabola is y equals x squared. Parabola. That is a mother function. A cubic function looks like this. This is cubic. It's y equals x cubed. It's called a cubic function. There's a square root function. It starts at a very specific spot and then shoots out like that. This is y equals the square root of x, and it's a root function. A v is a mother function. This is absolute value, y equals absolute value of x. And that's a super important one as well. This one right here is an exponential function. Exponential. This is really popular right now because of coronavirus. Coronaviruses grow exponentially, and that's why they're always trying to flatten the curve on these kinds of diseases. That's written as y equals a to the x. That's an exponential function. A rational function. Rational functions have a hiccup. They go like this, and then they skip over to the other side. That's all one function. That's y equals 1 over x. Again, these are called rational functions. Okay, what am I missing? Lines, parabolas, cubics, roots, absolute values, rationals. I think those are there's probably 30 of them, but these are the ones that are most important for this class that you should definitely be aware of. And we're going to want you to be able to kind of look at something and be like, oh, that's a rational, or oops, that's a parabola, or a quadratic. Oh, that's a cubic. Okay, and so it might be a good idea to start getting used to seeing these kinds of things and being able to say, ooh, I know what equation that is. You could even make some flashcards for these 7 things if you wanted to make sure that you're a pro at identifying the mother functions. In fact, we'll dedicate entire chapters to some of these mother functions. For example, in chapter 7, it's all about root functions. In chapter 6, it's all about rational functions. In chapter 8, it's all about parabolas and quadratics. In chapter 5, we'll be talking about exponentials, and so on. So just it's nice to get used to seeing these mother functions. Again, they're functions because they pass the vertical line test. Well, that's it for today. Thanks so much for watching. Good luck on your homework. And if you have any questions, feel free to reach out. I'd love to help. Send me a text and we'll help you out. Okay, we'll see you in our next class. This is Brother O signing out.